Hello geometry students, and welcome to a video that focuses on translations in the coordinate plane. So translations in the coordinate geometry. And we're going to focus on translations at first, and then we're going to do a couple that are a combination of translations with reflections. Okay, so first of all, just another way to think of the word translation is to vertically and or horizontally slide a figure. We're sliding it. And just to emphasize again, that when we translate or slide something, we don't turn it, we don't rotate it, we don't reflect it. It just slides without changing at all its orientation. All right, in symbolic form, there's a couple ways to symbolize this, but in coordinate geometry, we're going to think of the coordinates, which is x, y, and they go to x plus h, comma, y plus k, where the h represents a horizontal slide or shift, and the k represents something vertical. It's happening to the y's, so that's a vertical slide or shift. Okay, so on this handout, we're not going to do every problem. We're going to do, on the notes, you're only responsible for completing the problems 1, 3, 6, 7, 8, 9, 10, and 11. So that's still a lot, but we're not going to do 2, we're not going to do 4 or 5, and we're not going to do 12. Okay, so let's look at the first example. And I don't think it's going to be a big surprise how this works. I think it's going to be fairly straightforward, except here I'm going to use the rule rather than focus on just counting on the graph. That's the only difference between now and what we've done before. So we're going to first do what we normally do, and I'm going to plot the pre-image, which is the rectangle QRST, and so go ahead and plot that. Okay, so I've plotted the pre-image, and what I've also done is I've written the rule right here, right above where the image coordinates are going to go. I've written the rule. And to the left of that, I've written the XY points that we already have. So these are the pre-image points. This is the rule that we're going to use to apply to the pre-image points to get the image points. And then once we've done that, we're going to plot those points. Rather than counting from here, I want to focus on getting the coordinates first. So here's how it works. -6 is the x here. So -6 plus 5 is -1. -1 plus 7 is +6. -3 plus 5 is 2. 1 plus 7 is 8. 1 plus 5 is 6. -5 plus 7 is 2. -2 plus 5 is 3. And -7 plus 7, that's 0. Okay, so notice I'm not even thinking visually. I'm just adding numbers, adding and subtracting numbers. And I just want to make sure you guys are really solid and strong with that skill so that we can, we can be successful in this math class and in future math classes. So I want you to try to really hone in your skills and just get really comfortable, if you're not already or if it's been a while, just adding and subtracting these positive and negative numbers together. Now I'm going to plot them. So I have -1, 6. I'm just going to plot these 4 points and come back to you. Okay, so there it is. So I've plotted my pre-image in blue, my image in green. It does look strangely like the image is wider, a wider rectangle, but they're not. They're the same. And there's the first one. Now let's try number 2. Why don't you guys do the same thing? Plot the points. Write the original 4 points next to what their images will be, and write this transformation rule right above so we can just kind of see it right next to each other, and then we'll compare when we fill in the numbers. Okay, so see how this one goes. Okay, so there's the pre-image. There's a rhombus. There's the same rule that's written. I just wrote it right here above the points. Here's the given points. These are the same points that I graphed, my J, K, L, and M right there. And now I'm just going to apply the rule. So I'm going to fill in those numbers. You fill them in. You fill them in also and see how you do. Okay, now I wanted to show you the next step together. I wanted to work on actually plotting these points together because this time something that makes it a little bit harder to kind of focus on, and that's these are going to overlap. The pre-image and the image will overlap because this transformation is not far enough to get the image completely out of the pre-image, and you'll see what I mean right now. So let's plot -2, 5. -2, 5 is right there. See, it's right inside the image, and that's our J prime. And then 2, 6, that's nicely outside of the image right there, and there's our K prime. And then 1, 2, that's our L prime, and that's also nicely outside of the image, and that's L prime. And then M prime is negative 3, 1 right there. Now, that's okay that it overlaps, but it does overlap. So let's now connect our new rhombus, our image rhombus. Connect it together. And then when we shade it, we're going to get sort of a blue-green in that overlap because there's an overlap section there. So when I shade it, this rhombus gets to be blue, so that little area is blue-green. That's okay. That's what happens here. Okay? So there's the second one. We're also going to do number 6. So we're skipping 3, 4, and 5. We skipped 2, and we're skipping 4 and 5. We're going to skip up to 6 now. So let's see what happens with 6. It's just going to be another overlap, and I just want you to try this trapezoid, overlapping the trapezoid, and we'll compare notes when you're done. Okay, there's the trapezoid. Why is it a trapezoid? A trapezoid has one pair of parallel sides. This is not an isosceles trapezoid because the bases are parallel and the sides are not equal. So it's not isosceles trapezoid, but it is still a trapezoid. And when we apply our rule, let's see what we get for our points. Okay, so it can look really confusing when you first graph it. Let's just take a look at what it looks like once we shade it in. Always hold your ruler really still or mess things up, especially if you're using a pen like I am. I gotta be careful. I use a pen so you guys can see it. I use a pencil if I'm doing math. Something I'm trying to really figure out, I use a pencil. Alright, so here's the pre-image. That's one trapezoid, and here's almost moved completely out of it, but didn't quite escape it, did it? It's overlapping still, and here's the second trapezoid, and there you go. Okay, let's look at our next problem, which, again, looking at the numbers up here, our next problem is number 7. So let's look at number 7 on the next page. And so this time, we're not going to make the transformation. It's already there. We're going to describe the rule. So let me tell you how to describe the rule. I'm going to actually make a triangle to describe the rule. So here's how I'm going to do it. I'm going to take any point. I can choose any of the 3 points. I think I'm going to choose either D or F because it looks like E is going to have a little bit more overlap. So I'm just going to choose, I'll choose D up here. So it seems like a little bit more in the open. And I'm just going to make a line. And I'm actually going to make a whole triangle out of this to help me figure out what happened here. So to go from D to D prime, we have to go up vertically, and I'll just use my other color here. So we have to go up vertically from here to here. This is a counting problem. You're just really going to count. So up vertically, and then over horizontally. Actually, which order we go? Well, these are x, y coordinates. So we're going to consider the horizontal first. So this x, it went from here to here. It went 1, 2, 3, 4, 5, 6 units. Let me count one more time. Maybe I was off by 1, 2, 3, 4, 5, 6, 7 units. And it went in the positive direction. And the y went up. To get from this point to this point, it had to go up 1, 2, 3, 4 units. So y is 4. So the rule is going to use that. It's just going to go from, it's going to add 7 to the x's and 4 to the y's. So our rule, x, y, is going to go to x plus 7, y plus 4. Okay, had it gone down, now all of these will do the same thing. Going from f to f prime will also go up and over, or over and up. To the right, and it's all positive, right? Nothing goes to the left. You're looking from the pre-image to the image, always goes in the positive direction for this problem. Okay, let's try number 8. You guys try it. Draw the line, make a triangle out of it, and see what you get. Okay, this time I drew some arrows. So I chose P for my point. So going from P to P prime is this line right here. When I broke it down to what's actually called components, I made my right triangle, and it goes this way. See the arrow there? I went to the left 4 units, so x goes minus 4, and then I went up 2 units. So my rule, x, y, so x, comma, y will go to x minus 4, y plus 2. Okay? Okay, so this next problem is called a composition of functions. And this is not just, this is where a lot of confusion comes in because we're doing two things here. And the tricky thing is we're not doing them both to the image. We're going to create we're going to go from from the pre-image. We're going to go from the pre-image to an image using the first transformation. That image will be the pre-image for the next transformation. So we're not going to start over again with this transformation. We're not even going to look at these points when we do this translation. We're going to look at the points we get from the reflection. Okay, so what I like to do when I do this is I make a middle, sort of a middle image that's between the pre-image up here and the final image here, and I'm going to make that one dashed. So let's first plot the pre-image. That's easy. Okay, so there is the pre-image. Now what we're going to do is we're going to reflect over the x-axis, which means this is not a translation, this is a reflection. So you may choose to go back to the notes from Friday. This is lesson 5-2 notes. And you may choose to refresh your memory on what do you do when you reflect over the x-axis. And that's the very first one that we did. We switch xy to x negative y. Or you can do it visually. It's completely up to you. All right, but I just wanted to remind you where that is in case you want to look at it. So we're going to reflect this over the x-axis, which means I'm going to do it visually. There's my y prime. This is up 1, 2, 3, 4, 5, 6, 7. So down 7. There's my x prime. That's kind of a middle. Actually, I'm not going to call those primes because of the way the answers are shown here. I'm just going to not even name them. Okay, I'm just going to leave them unnamed, and that's okay because this is not going to be my final answer. It's just going to be part of the process to the final answer. This z will come down here. And so here, let's just kind of make this a dashed triangle. We won't even use the ruler because, like I said, it's just a middle step. All right. Now we're going to take these, and if you want, you can write down the coordinates, or you can use the counting method. Either way, you're more comfortable. Each point, now this point right here is my y. That's where y went. So I think I'm going to write these rules down. So let's write the rule down here. So we have -2, -1. We have the first one was actually this one, which is -3, -7. And then the last one, which would be this one, would be -5, -2. Now that's where we're going to start for this translation. So all of these xy's are going to follow the rule x plus 9, y plus 2. I'm not looking at these anymore. I'm looking at what I found here after the reflection, because I'm now translating the reflected image, this one. Okay, so let's see. We have -3 plus 9 is 6. -7 plus 2 is -5. -2 plus 9 is 7. -1 plus 2 is 1. -5 plus 9 is 4. And -2 plus 2 is 0. These are my points. Actually, I should have put them right there. There wasn't quite room in between here, but that's where I should have put them. So I'm actually going to graph 6, -5, 7, 1, and 4, 0. So let's plot those points and see what we get. Okay, so there it is. There's the final image. And just to review what we did here, we took the original image coordinates that were given and we plotted the original triangle. Then we followed step A, which was to reflect that triangle here to here. Then we looked at that reflection and we wrote down all of the ordered pairs from that reflection. Once we have those ordered pairs, now we're ready to apply B, which is the translation of this. So we took those ordered pairs that go with this dashed triangle and we applied the transformation rule that we were told, which is x plus 9, y plus 2, added them up, and then we got these points here, which are these points in here in our final answer. And now if you look at it, it almost looks like a rotation. And guess what? It is a rotation. We're not going to bother trying to find the center of rotation right now, but a lot of these, actually this one may not be. Sometimes when we do these combinations, they do end up being rotations, but I guess I was looking at it wrong because I think that the y would still be on the inside if it was a rotation. So yeah, it's not a rotation. Okay, there you go. So I'm going to make another video that shows the other two examples. I hope you found this helpful.